Welcome back. We're continuing to solve linear systems by elimination. So let's take a look at the following. We have the system of equations 7x plus y equals 5 and 7x plus 2y equals 10. Alright, so here's our linear system, and we should notice right off the bat that we have this one variable that's in both equations that has the identical coefficient of 7, a positive 7. So that means that we can subtract these two equations, which will essentially cancel out the variables, leaving one equation with one variable that we can solve for. So let's go ahead and do so. Here's equation 1, here's equation 2. So let's subtract 2 from 1, like so. So we have 7x plus y equals 5. We're going to subtract the entire equation, equation 2. We have 7x plus 2y equals 10. All right, so before we do so, we're going to distribute this minus sign. So instead of subtracting the equation, we're going to add the opposite of the equation. So let's rewrite the first one. We have 7x plus y equals 5. Let's go ahead and distribute the minus sign. So we're going to add the opposite. The opposite of 7x is minus 7x plus, or we're going to distribute this minus sign, so we have a minus 2y. Minus 2y is the opposite of 2y. The opposite of 10 is minus 10. All right, now we can go ahead and add down the columns. Those two terms will cancel. 1 minus 2 is a minus 1, or just minus y. 5 minus 10 is a minus 5. We can go ahead and divide both sides by a minus 1, canceling these negative signs, which gives us y equals 5. We have a value for one of our variables, and like solving any other linear system, we can plug that back into either of our equations to find the other value of the x value. Here we just have y, so we can just use the first equation. So we have 7x plus y, which is 5, equals 5. If you notice, we have 5 on both sides, so we can just cancel those straight just like this. Same thing as subtracting both sides by 5. So we have 7x equals 0. And if we divide both sides by 7, we just have x equals 0. All right, so x equals 0, so we have both of our values for our solution point. So let's go ahead and write it. The point where these two lines intersect is 0, 5. And that's the solution to our system of equations. Not a whole lot to it. We should be very good at this by now. We're solving linear systems by elimination, and in particular, we're using subtraction. So let's look at a few more. We have x over 2 plus 2y equals 4. And we also have x over 3 plus 2y equals minus 7. So this is our linear system of equations, and we should notice that we have one variable, the y variable, that has the identical coefficient in both equations. So this is easily set up as subtraction. We could subtract equation 1 from equation 2. So let's rewrite equation 1 as x over 2 plus 2y equals 4. We're going to subtract the second equation from equation 1, so we have x over 3 plus 2y equals minus 7. Before we do so, we're going to distribute this minus sign. So instead of subtracting equation 2, we're going to add the opposite of equation 2. So we have x over 2 plus 2y equals 4. We're going to distribute this minus sign, so we're going to add the opposite. The opposite of x over 3 is minus x over 3. The opposite of plus 2y is minus 2y. Minus 2y. The opposite of minus 7 is a positive 7. These two terms will cancel, so we have x over 2 minus x over 3. Let's go ahead and do this to the side. X over 2, excuse me, minus x over 3. This is the same as 1/2 x minus 1/3 x. Let's go ahead and subtract the coefficients using cross multiplication. So we have 1 times 3 is 3, minus 2 times 1 is 2, divided by 2 times 3 is 6. 3 minus 2 is 1, so we have 1 over 6. So we have 1 over 6 x, or just x over 6, equals 11. We should be very familiar with this. Adding and subtracting fractions whose denominator is different, we can use a cross multiplication method just like this. We did very numerous videos on that, so we should be familiar with it. Let's go ahead and solve this by multiplying both sides by 6. That'll cancel the denominator here, giving us just x on the left-hand side. 6 times 11 is 66. So we have x equals 66 for our first value. We can go ahead and plug that into either equation. Let's go ahead and use equation 2, and we can find our value for y. So we have 66 divided by 3. Plugging into equation 2 for x, we have 2y equals minus 7. 66 over 3 will reduce. That'll be 22. So 3 will go into 66 22 times. Plus 2y equals minus 7. Let's go ahead and subtract 22 from both sides. We want our variable on the left-hand side, everything else on the right-hand side. So we have 2y equals minus 7 minus 22 is a minus 29. We can isolate our variable by dividing both sides by 2. Those two terms will cancel. So we have y equals minus 29 halves. We have a value for our solution for both x and y. So let's go ahead and state our solutions. We have x is 66, y is minus 29 over 2, and that's our solution to our system of equations, or where these two lines intersect. This is the point where they intersect. Very important that we understand that, especially when it comes to graphing. All right, let's go ahead and squeeze in one more here. We have 6x equals 12, and 6x minus 5y equals 8. All right, so we have two equations here, and we notice that they both contain a 6x, so we can subtract these two equations from one another. So let's go ahead and do so. Let's write the big equation first. We have 6x minus 5y equals 8, minus the second equation, 6x equals 12. Let's go ahead and be sure we're lining them up. And before we subtract them, we're going to distribute that minus sign in the second equation. So we'll essentially be adding the opposite of this equation. The opposite of 6x is minus 6x. The opposite of 12 is minus 12. We're not going to write anything for our y place right here. We're just going to bring it down. These two terms will cancel, so we're just going to bring down our minus 5y. And 8 minus 12 is minus 4. Let's divide both sides by minus 5 to solve for a positive y. We have y equals, if we cancel these two negative terms, y equals 4 over 5. So we have one variable, or one value for one variable. Let's go ahead and plug it into either equation. If you notice here, we have a term 0 times y. So we can actually just divide both sides by 6 and get x equals 2 for our other variable. But let's go ahead and practice. So we can show that this indeed works for both equations. So let's plug in y into our second equation. So we have 6x minus 5 times y, which is 4 over 5. Excuse me, that's 4 over 5 equals 8. And let's go ahead and solve for x. These two terms will cancel. So we have 6x minus 4 equals 8. Let's go ahead and add 4 to both sides. Recall that this should equal x equals 2. So this is actually just a good check. 6x equals 8 plus 2 is 12, or excuse me, 8 plus 4 is 12. And actually we have the same thing as we did up here. The same relation. Dividing both sides by 6, x equals 2. Which gives us our second value. And we know we're correct because we can divide both sides by 6 here and get x equals 2. So let's state our solution. We have the solution point 2 and 4 over 5. That is the solution for this system of equations. It's where the point where these two lines will intersect. So we're solving linear systems by elimination using subtraction, which we can do if we identify the same term in both equations. Here we had 6x in both equations, so we can subtract them from each other to find one of our values for our variable y. So we're using elimination, and in the next video we'll actually be looking at an application of solving a linear system for a real world situation where we can actually subtract one equation from the other to get the solution point. So I'll see you in the next video.